Hello, my name is Mohammadullah Hakim Ebrahimi. I'm a PhD researcher at the University of Montpellier in France. I'm working on a project between Kabul or Afghanistan and France. The title of my paper is Sustainable Construction for Affordable Housing Program in Kabul City. In Afghanistan, earth is the main construction material. Most of the people live in earth-made houses. A variety of forms exist, as we can see, from courtyard to different other types. Sandripe and cope are the main construction techniques that we use traditionally for thousands of years. We call the cope locally paksa. Construction with earth has a number of environmental benefits, such as local material use, low embodied energy. As you can see here, earth brick has the lowest embodied energy compared to concrete. High thermal mass capacity, less use of non-renewable energy. Self-built construction, and importantly, low maintenance cost. To study Kabul city, there was two rapid demographical change. One occurred in 1979 and other in 2001, and this caused that we need to build a lot of affordable housing for people who migrated to Kabul. In 1979, when Russia attacked Afghanistan, all the people came to Kabul city. We can see the graph, there's a very rapid change. Later in 2001, when US Army came to Afghanistan, again, we have a lot of people migrated to Kabul city, mainly for security reason. There was better job opportunity and better education for their children. Now in Kabul, we have around 70% of the houses informal settlement. As you can see, they all made with traditional earth elements, but we have also those people who can afford to use some modern materials. For Kabul city, based on UN Habitat, we need 41,000 houses to be built between 2015 and 2025. Traditional housing in Kabul city, we have courtyard houses mainly. These courtyard houses has a bioclimatic approach. We can see for the south face, we have a peak which prevents sand during summer and when let the sun during winter to enter the rooms. We live in large and extended families, and we have south face rooms like this, which we benefit during the winter, and north face rooms for summer. The use of imported modern material like concrete and steel, as we see structure, causes more energy demand for the housing. We can see a lot of the houses which built newly in Kabul, they use modern material. They have a lot of they don't use a bioclimatic approach. There's a lot of window which is facing the street. It's really cultural conflict. So we need to use traditional material rather than this modern materials. For the soil location, we use three soils, three types of soil from three districts. Two of these districts, like Bagman and the Sabs, already provide bricks to the Kabul city, to the center. And this soil will be characterized later in the other slides. We can see here the geological map of the site, of all three sites, and on this graph we can see the exerted friction. As we can see, the Sabs and Urbanism soil are quite similar. They all have calcite, quartz, and muscovite and chlorite. They're very similar. But Bandeghazi is a little bit different because for Bandeghazi we don't have a lot of chlorite and muscovite. The wet sieve analysis was performed to find the particle site distribution. Two out of the three soil has very fine grain. Desabs and Organdi. Desabs has almost 98% clay and salt, while Organdi has 93.5%. They both are more than 90%. So, but Bandeghazi has is well-graded soils, as we can see. For the other limits, we can see all three soils are slightly plastics. The zero plasticity index shows that they are slightly plastic, and Bandeghazi, Desabs in Organdi has medium liquid limits, where Bandeghazi has weak liquid limits. For the soil suitability analysis, we use AFNOR French code and MOT Spanish code. Both has developed polygons and shows those soil which fit inside these soils based on their liquid limit and plasticity limit. They are suitable. We can see the subs and around there or inside this polygon. For the Proctor test, we just wanted to find the drying apparent density of these three soils. We can see Bandeghazi soil has the highest apparent density and the minimum water content. While for the subs and they have almost similar dry density, but variation in water content. For Arvandi, we have 30%, around 40%, but for the subs around 70%, 17%. This dashed blue and green line shows the reconstituted soil, because for compressed stabilized earth blocks, which we use cement, these two soil are very fine grained. There's not a lot of sand, so we used around 75% sand with this, and then we did this is the result for the dry density. For the mixer proportion, from that three soil, we developed three types of elements, like sun-dried bricks, which we use traditionally, and two modern elements like compressive earth blocks and compressive stabilized earth blocks, which we add cement to it. The dry compressive strength of these three elements, like sun-dried brick, compressive earth block, and compressive stabilized earth blocks, shows that CECB, which has cement, has higher compressive strength than CEB without cement, and in turn CEB has higher compressive strength than sun-dried bricks. This dashed blue line shows correlation between dry density and compressive strength. It shows the more the dry density is, the more compressive strength we get out of these elements. We can see in this Bender intensity index that all elements has a higher compressive strength than 2 MPa. Using cement, it shows that using cement is not efficient, because we use a lot of cement to get almost similar compressive strength. So in that case, we can see sun-dried brick and CEB has a good compressive strength. Will not use CECB or cement, because it's not an efficient way of using cement. For the Kabul climate, we have a semi-arid climate, which has cold winter up to -8 and warm summer up to 34 degrees. So this figure shows that there is an energy demand for Kabul, and we also need insulation because there is big variation of climate during summer and winter. The thermal conductivity, as we can see, this is the dashed green line shows the thermal conductivity for the subs, which is 25% more higher than Organde, and it's 20% higher than thermal conductivity of glassware. Element type, we can also see that element type, even if whatever element is, it's not really affecting the thermal conductivity of this soil. And we also can see that since the thermal conductivity is high, we need to develop a prefabricated panel mixture of soil and wheat straw to use for the external walls to prevent this thermal conductivity. And also heat transfer capacity, we can say there is a correlation between dry density and heat transfer capacity. The more the dry density is, the better the thermal conductivity is. So heat thermal conductivity related to the type of soil element, as we can see here. The finding of this paper showed that the sustainable design for affordable housing in Kabul should necessarily learn from the past to invest in the local identity. The importation of Western-style housing revealed apparent cultural conflict and significant environmental issue. So we need to conserve traditional housing system in Kabul city. Considering the environmental issue, stabilization of earth with Portland cement is not efficient. So CECB or compressed stabilized earth block is not interesting for this study. The dry compressive strength of CEB is higher than sun-dried bricks, as we see on the figure. So earth architecture with modern method like CEB provide a reasonable answer to overcome the problem of affordable housing for Kabul city. The subsoil gives a better compressive strength, as we saw. Therefore, will be chosen as the reference soil for this study.